Hi students, my name is Ratnaprabha Patil. Today we are going to continue with your topic electrostatics, in which in last lectures we have studied about potential energy. Now in your syllabus 8.7 point from electrostatic, that is conductors and insulators, free charges and bound charges inside a conductor. This point is dropped from your syllabus for the academic year 2020-21. So from today we will start with the dielectrics and electric polarization. This point is 8.8 from your syllabus, that is dielectrics and electric polarization. So what are dielectrics? Dielectrics are insulators which stores electrical energy. This is because when such a substance is placed in an external electric field, its positive and negative charges are gets displaced in opposite direction and molecules develop a net dipole moment. This you will understand in polarization also. So if any dielectric material, dielectric को आप insulators भी बोल सकते हो, which stores electrical energy, it means उसमें क्या होंगे, अगर आपने external electric field dielectrics को दे दिया, then it will produce, or there will be the displacement of positive and negative charges in the opposite direction and molecules develop a net electric dipole. मतलब क्या, अगर आपने एक स्लैब लिया, रेक्टेंगल पीस लिया इंसुलेटर और डाइलेक्ट्रिक का, अगर और आपने उसको क्या किया, एक एक्सटर्नल इलेक्ट्रिक फील्ड दी, तो उस रेक्टेंगल के एक साइड में पॉजिटिव चार्ज गैदर होगा और एक साइड में निगेटिव चार्ज, that is there will be the displacement of charges, और बाद में क्या होंगे, वो दोनों अपोजिट साइड में क्या हो जाएंगे, गैदर हो जाएंगे. उसमें क्या होगा, उसके बाद क्या होगा, तो देयर विल बी द डाइपोल मोमेंट, एंड दिस इज कॉल्ड polarization of material. Such material are called as dielectrics. Dielectrics are insulating materials or non-conducting. You can say insulator मतलब क्या, they are not conductors or non-conductors or non-conducting substance which can be polarized through small localized displacement of charges, just like glass, wax, water, wood, mica, rubber, stone or plastic. These examples are given in your book, that they are called as dielectrics or insulating materials or non-conducting substances. Now dielectrics can be classified as polar dielectrics and non-polar dielectrics, which you can see on your screen also. So what is meant by polar dielectrics? Molecules in which the center of mass of positive charge does not coincide with the center of mass of negative charge. So these are called as polar dielectrics. This is because of asymmetric shape of molecules, and these molecules which are polar dielectrics, they are polar molecules. They have permanent dipole moment of the order of 10 raised to minus 30 coulomb meter. In your book you can see two, in your book or in diagram you can see two images of HCl and H2O. You can see here HCl and H2O. Water molecules is having bent shape with its OH bond. मतलब OH bond जो होगा ये आपने केमिस्ट्री में पढ़ा होगा. That is, water molecule has a bent shape with its two OH bonds and they are inclined at an angle of 105 degree. Okay, and this water is having high dipole moment which is 6.1 into 10 raised to minus 30 coulomb meter. So आपको example में भी दिख रहा है that there is an angle in between the bond OH on the both side and this bond is making, or this bond is inclined at an angle of 105 degree. So such a molecules which are polar molecules, polar means what? The molecules which are having a symmetric shape. These molecules are called as polar molecules, and when such a molecule are the polar dielectrics, means their center of mass of positive charge does not coincide with the center of mass of negative charges. Then another dielectrics is non-polar dielectrics, which is a molecule in which the center of mass of positive charge coincide with the center of mass of negative charges. So you can see in the images also there is a two molecules H2 and CO2. These molecules are having symmetrical shape and have zero dipole moment in the normal state. The dielectrics, like you can see the examples, hydrogen, nitrogen, oxygen and CO2, that is benzene or methane, are made a non-polar molecules, or you can say they are called as non-polar dielectrics. You can see in the image there is a no angle in between the H and H bond, just like that C and O bond, and such a molecules are called as non-polar dielectrics. Now we are going to study a next point, which is polarization of non-polar dielectric in an external electric field. So what is meant by non-polar dielectric? The molecules in which the center of mass of positive charges coincides with the center of mass of negative charges. Okay, and these are the non-polar molecules. Examples which you have seen, that is hydrogen, that is H2, CO2, O2. These molecules are non-polar dielectrics. So if हमने क्या किया, you can see in the image that in the absence of electric field, the molecules are just like this. Okay, the molecules are just like this. In presence of external electric field, you can say E0, then there is a displacement of charges. Okay, so in presence of an external electric field E0, the center of positive charges in each molecule of non-polar dielectric is pulled in the direction of electric field, that is A0. अगर आपने इलेक्ट्रिक फील्ड प्रोवाइड किया तो सेंटर ऑफ पॉजिटिव charges of each molecule of non-polar dielectric is pulled in the direction of E0. आपको E0 का डायरेक्शन कहाँ पे दिख रहा है? You can see in the figure that in the direction of external electric field, center of positive charges are displaced and negative charges are displaced in opposite direction. That is, centers of negative charges are displaced in opposite direction. The two centers are separated and the molecules get distorted. So originally molecule इस तरह से थे, that is non-polar. After that they get polarized due to application of external field. So due to this there is a distortion of molecule takes place after application of external electric field. The displacement of charges stops. आपने इलेक्ट्रिक फील्ड अप्लाई की लेकिन हमेशा मॉलिक्यूल्स डिस्प्लेस नहीं होंगे. वो कब तक डिस्प्लेस होंगे? When the force exerted by external field is balanced by the restoring force between the charges in the molecule. So restoring force क्या है? Tendency of the material to get its or to regain its original position. That is called as restoring force. आपने एक्सटर्नल फील्ड अप्लाई की, मॉलिक्यूल हमेशा डिस्प्लेस और कंटिन्यूसली डिस्प्लेस नहीं होंगे. दैट इज पॉजिटिव एंड नेगेटिव चार्ज विल नॉट बी डिस्प्लेस्ड कंटिन्यूसली. आफ्टर सम टाइम their displacements will be stopped due to restoring force of that positive and negative charges. Each molecule become tiny dipole having a dipole moment. Dipole क्या होता है? Di means two, pole मतलब two poles, that is plus and minus. So molecules क्या हो गए? Displace हो गए due to application of external field, and after that positive charge और negative charge क्या हो गए? Positive charge and negative charge are displaced in the opposite direction, and due to that dipole is produced. And dipole produce होने के बाद क्या हुआ? There is a tiny dipole. मतलब दो मोलिक्यूल का एक डाइपोल बना, दो पॉजिटिव एंड नेगेटिव चार्ज का डाइपोल बना, विच इज हैविंग अ मिनिमम और यू कैन से टाइनी डाइपोल मूवमेंट. And this induced dipole moment of different molecules अगर आपने ऐड किया तो आपको क्या मिल जाएगा? नेट dipole moment of that dielectric material in presence of external field. तो ये समझ में आया आपको जो मैंने आपको डाइलेक्ट्रिक्स और इलेक्ट्रिक पोलराइजेशन में बताया था. क्या? देयर इज अ व्हेन external field is applied, there will be the displacement of charges in opposite direction. लेकिन displacement कैसे होगा? Positive charge will displace along the direction of electric field. अगर positive चार्ज इलेक्ट्रिक फील्ड के डायरेक्शन में जा रहा है तो नेगेटिव चार्ज क्या होगा? पॉजिटिव अपोजिट डायरेक्शन में जाएगा इलेक्ट्रिक फील्ड के, एंड ड्यू टू दैट देयर विल बी द डाइपोल इज प्रोड्यूस्ड और टाइनी डाइपोल आपको दिख रहा है. एवरी मोलिक्यूल इज गेट डिस्टॉर्टेड इन पॉजिटिव एंड नेगेटिव चार्ज ड्यू टू एप्लीकेशन ऑफ external electric field, and this molecule is having some dipole. और आपको नेट डाइपोल निकालना है तो आपको क्या करना पड़ेगा? दैट इज यू हैव टू add the dipole, this tiny dipoles together to get an net dipole moment of this dielectric in the presence of external electric field. This is all about polarization of non-polar dielectric in an external electric field. Now we are going to see the polarization of polar dielectric in an external electric field. What is meant by polar dielectrics? Molecules in which the center of mass of positive charges does not coincide with the center of mass of negative charges, and you have seen its example, that is HCl, H2O. These are the examples of polar dielectrics. So how these molecules or how these materials will behave when external electric field is applied, or how polarization takes place in polar dielectrics. Molecules have tiny permanent dipole moment due to thermal agitation in the material. In the absence of external electric field, these dipole moments are randomly oriented due to temperature, means molecules in that material is moving here and there, and due to that, and due to thermal agitation, means temperature, environmental temperature, the molecules which are having tiny dipoles, you can see here there is a tiny dipole, and due to thermal agitation these dipoles are moving randomly in that material in absence of external electric field, and due to this dipole moment of such a material is randomly oriented. ओके जब आप देख सकते हो इन फिगर 8.21 दैट ड्यू टू टेम्परेचर और एनवायरमेंटल टेम्परेचर यू कैन सी डाइपोल मोमेंट जो भी मॉलिक्यूल्स का है वो कैसे है, इट इज़ नॉट प्रॉपर, यू कैन से इट इज़ रैंडमली ओरिएंटेड. इट इज़ बिकॉज उस मटेरियल के एक एज पे पॉजिटिव चार्ज और एक वन साइड पे पॉजिटिव और अदर साइड पे नेगेटिव चार्ज, ऐसा कुछ है क्या? नहीं, दे आर रैंडमली ओरिएंटेड एंड ड्यू टू दैट इट्स डाइपोल मोमेंट is randomly oriented. When external field is applied, dipole moment of different molecule are tend to align with the field. जैसे आप क्लास में करते हो, अगर आपकी क्लास में टीचर नहीं है तो आप क्या करोगे, you are randomly oriented, means you can whisper in with each other, or you are moving here and there from one bench to another, just like this. Means without applying external electric field, molecules, that is dipole moment of these molecules are distributed randomly. But after application of external electric field, आप टीचर क्लास में आए तो आप कैसे बैठोगे, in proper way, systematic way. Just like that, these molecules are tend to align with the field. वैसे होगा जैसे पहले हुआ था, that is positive charge will get displaced or get orient in the direction of applied electric field, that is the dielectric develop a net dipole moment in the direction of external electric field. Dipole moment per unit volume is called as polarization for linear isotropic dielectrics, which is given by equation P is equal to P is dipole moment x E into E. E is x, E is the electric susceptibility of that dielectric medium. So in non-polar dielectrics, there is a no dipole moment or dipole before application of external electric field. After application of electric field, there is a production of, or you can say क्या होगा, there will be the displacement of positive and negative charge. Positive charge will displace in the direction of electric field and negative charge will displace in opposite direction of electric field, and due to this there is a creation or production of dipole in terms of non-polar dielectric materials. But in terms of polar dielectrics, there is a these materials are tiny permanent dipole before applying the external electric field also, means they are present in the form of dipole. After application of that external electric field, these dipoles are tend to align in the direction of applied electric field. Okay, this is the difference in between polarization of polar and non-polar dielectric. Now we are going to see a next point, that is reduction of electric field due to polarization of dielectric. Here you can see three images and we are going to study this reduction of electric field due to polarization of dielectric with the help of these three figures. So when a dielectric is placed in an external electric field, value of the field inside the dielectric is less than the external field as a result of polarization. आपने पहले भी पढ़ा दैट कोई भी मटेरियल हो, आपने क्या किया, डाइलेक्ट्रिक मटेरियल, उसको आपने इलेक्ट्रिक एक्सटर्नल इलेक्ट्रिक फील्ड प्रोवाइड की, तो वैल्यू ऑफ फील्ड इनसाइड दैट डाइलेक्ट्रिक मटेरियल और डाइलेक्ट्रिक इज लेस दैन जो भी आप फील्ड अप्लाई करोगे एक्सटर्नल फील्ड, और जो फील्ड डाइलेक्ट्रिक में प्रोड्यूस होगी इज ऑलवेज लेस. इट इज़ बिकॉज ऑफ पोलराइजेशन. क्या हो रहा है, पोलराइजेशन हो रहा है. पोलराइजेशन मतलब क्या, दो डिफरेंट पोल एक ही मटेरियल में आपको मिल रहे हैं. मटेरियल का एक साइड है पॉजिटिव, एक साइड है निगेटिव. ओके, अ रेक्टेंगुलर डाइलेक्ट्रिक स्लैब प्लेस्ड इन यूनिफॉर्म इलेक्ट्रिक फील्ड एक्टिंग पैरेलल टू इट्स फेसेस. तो आपको यहाँ पे क्या दिख रहा है, दो प्लेट्स है, एक निगेटिव प्लेट है, एक पॉजिटिव प्लेट है. ई का डायरेक्शन आपको दिया है और ड्यू टू दिस अप्लाइड इलेक्ट्रिक फील्ड डाइलेक्ट्रिक क्या हो गया, टूवर्ड्स निगेटिव प्लेट there will be the positive charge, towards positive plate there will be the negative charges. Like that, positive charges displaced in the direction of electric field. इलेक्ट्रिक फील्ड का जहाँ डायरेक्शन है वहाँ पे क्या होगा, पॉजिटिव चार्जेस डिस्प्लेस होंगे और इन अपोजिट डायरेक्शन नेगेटिव चार्जेस. इलेक्ट्रिक चार्जेस आर नॉट फ्री टू मूव अबाउट द डाइलेक्ट्रिक. ये इंसुलेटर है तो देयर विल नॉट बी एनी फ्लो ऑफ चार्ज. डाइलेक्ट्रिक क्या है, इंसुलेटिंग मटेरियल और यू कैन से नॉन कंडक्टिंग मटेरियल. सो ड्यू टू दिस सिर्फ क्या होगा, आफ्टर एप्लीकेशन ऑफ एक्सटर्नल फील्ड देयर विल बी द production of dipole moment in that dielectric. Electric field produces a slight rearrangement of charges within atoms, that is alignment of atom with the field. यहाँ पे जो है that is क्या हुआ, एटम में जो चार्जेस है उसका क्या हुआ, अलाइनमेंट हुआ आफ्टर एप्लीकेशन ऑफ external field. charges move only over distance that are less than an atomic diameter. मतलब चार्जेस क्या हो रहे हैं, सिर्फ डिस्प्लेस हो रहे, they will not come out from the atom. ओके, सो चार्जेस का डिस्प्लेसमेंट उतना ही होगा जितना एटम का डायमीटर है. Dipole movements, there is an apparent sheet of positive and negative charges, and polarization field in the insulator E0, the net field is E dash inside the dielectric is, तो polarization क्या होगा, E dash is equal to E plus E0. E0 क्या है, field produced inside the dielectric due to application of external field. E is applied field, तो net field inside the dielectric क्या होगी, E minus E0, E minus E0, not E plus E0. ओके, फर्स्ट फिगर में आपको क्या दिख रहा है, व्हेन आपने क्या किया, डाइलेक्ट्रिक इज प्लेस्ड इन एन एक्सटर्नल इलेक्ट्रिक फील्ड, और उसके बाद क्या हुआ, डाइपोल बिकम्स अलाइंड, ये आपको फर्स्ट फिगर में दिख रहा है. आफ्टर दैट इंड्यूस्ड सरफेस चार्ज ऑन द डाइलेक्ट्रिक establish a polarization field E0 in the interior. Due to application of external field, there will be the induced polarization, or you can say electric field inside that field generate होगी inside that dielectric which is E0, and that net electric field E dash which is in the direction of applied electric field, और इसका इक्वेशन क्या होगा, E dash is equal to E minus E0, not plus E0. ओके, जितना ज़्यादा आप इलेक्ट्रिक फील्ड अप्लाई करोगे, दैट इज ग्रेटर द अप्लाइड फील्ड, ग्रेटर इज द डिग्री ऑफ अलाइनमेंट. जितना ज़्यादा फील्ड स्ट्रेंथ होगा या जितनी ज़्यादा इलेक्ट्रिक फील्ड अप्लाई करोगे आप, ग्रेटर विल बी द डिग्री ऑफ अलाइनमेंट ऑफ डाइपोल्स. हैंस जितना ज़्यादा इलेक्ट्रिक फील्ड होगा उतना ज़्यादा पोलराइजेशन होगा. ओके, एंड डाइपोल मूवमेंट डिसअपियर होंगे और मॉलिक्यूल अपने पोजीशन पे वापस आ जाएंगे व्हेन आप एक्सटर्नल फील्ड क्या करोगे, रिमूव करोगे. Okay, this is all about reduction of electric field due to polarization. Okay, and next lecture we will study the capacitor and capacitance. Means what is meant by capacitor and capacitance, combination of capacitors and parallel plate capacitors. Okay, this is all about this lecture. Thank you.